Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss differential equations. In this chapter, we are going to discuss the sums in the exercise 7.4. In the previous class, we have discussed the concepts of exercise 7.4 as well. We have discussed some questions in this exercise. I hope you have understood the concepts of this exercise and I hope you have learned well the sums in this exercise what we have already discussed. I hope you have done the homework also. Whatever I have given, whatever I assign you as homework. Haven't you, my dear children? Right. Now come to the question number 15. Find the equation of a curve passing through the point 0, comma 0 and whose differential equation is y dash is equal to e power x into sin x. Okay, my dear children. Hereafter, the questions are given on application of differential equations, on the concept of application of differential equations. Okay, my children. Right. In the previous questions, the differential equations were given directly. Here, we have to apply that knowledge of solving a differential equation of first order, first degree differential equation by separating the variable separable method. Okay, my children, are you ready to listen the class? Right. Now come to the solution part. What is the given differential equation y dash is equal to e power x into sin x? Okay, my children. Given y dash is equal to e power x into sin x. What is meant by y dash? S dy by dx. Okay, my children. Is equal to e power x into sin x. Because y dash is equal to dy by dx. Both denote the same. Okay, my children? Right. So, here we have to solve this differential equation by using the knowledge of separating the variables method. Okay, my children? Right. Here, this entire function is in the variable x. There is no function in the variable y. So let us separate the variables. Let us transpose dx to RHS. Then what will you get? Dy is equal to e power x into sin x dx. Understood this step, my children? I have transposed by dx to RHS. Then it becomes into dx. So dy is equal to e power x into sin x dx. Understood this step, my children? Right. So here we have what we have done, separating the variables. Okay, my children? By separating by separating by separating the variables we got this step. Okay, my children? After getting this step, what should we do? Integrating on both sides. Integrating on both sides. Then what will you get? Integral dy is equal to integral e power x into sin x dx. Understood this step, children? Integral dy is equal to integral e power x into sin x dx. Okay, my children? Right. This implies integral dy. What is the value of integral dy? Y. Understood this y, my children? Right. Now come to RHS. Integral e power x into sin x dx. Here we have to bring back the knowledge of integration by parts method. Okay, my children? Integral uv formula. Because here e power x is one function, sin x is another function. Then first of all, what should we do? We have to arrange the functions in the order isolate. I late. Yes or no, my children? The first here this is exponential function and this is a trigonometric function. But the trigonometric function should be first and the exponential function should be second. But the functions are given in the reverse order. Okay, my children. So let us rearrange these functions. Integral sin x into e power x dx. Then it is easy to integrate this function. That is why we have to arrange the functions in this order only. Okay, my children, understood this point? Right. Here in LHS integral dx is equal to x. For LHS we use this integral formula. Okay, my children? Right. This implies y is equal to, now integral uv. U means sin x, v means e power x. Okay, my children. So first function, do you remember that formula, my children? Integration by parts. First function into integral of second function minus integral of d by dx of first function into integral second function whole dx. Yes or no, my children? First function into integral of second function minus integral of d by dx of first function into integral of second function. Okay, my children? Right. Then because integral uv dx is equal to u into integral v minus integral of d by dx of u into integral v dx whole dx. Okay, my children, by using this integration by parts method, we are finding the integral of this function. Understood this step, my children? By using this integration by parts method, we wrote this step. Okay, my children? This implies y is equal to sin x into integral e power x. What you get? E power x minus integral of d by dx of sin x. What will you get? Cos x. Yes or no, my children? Cos x into integral e power x. What will you get? E power x only into dx. Because integral e power x is equal to e power x dx. Integral e power x dx is equal to e power x and d by dx of sin x is equal to cos x. Okay, my children, understood this one? Okay, my children, understood one? Right. Now, again, we have to integrate. We have to integrate this one. Okay, my children, this implies y is equal to e power x into sin x, e power x into sin x minus of, again we have to integrate by using the same uv formula. First function cos x integral second function minus integral d by dx of cos x into integral e power x dx whole dx. Understood this step, my children? Again we have applied integration by parts. Okay, my children? Right. This implies y is equal to e power x into sin x minus cos x into integral e power x dx. We have written already. Integral e power x dx is equal to e power x only minus d by dx of cos x. What will you get? Minus sin x. Yes or no, my children? Minus sin x into integral e power x dx. What will get? E power x. Understood this step, my children? Here we have used new formula. What is that new formula? D by dx of cos x is equal to minus sin x. Understood this formula, my children? By using this formula, we wrote this part. And remaining cases, in the remaining parts, we have used already previous formula. Understood this step, my children? Right. By using the distributive property, we get this step. Okay, my children? Right. Actually, integral sin x into e power x dx value is nothing but y. Yes or no, my children? Right. This implies y is equal to e power x into sin x minus e power x into cos x minus y. Okay, my children? Understood this one? Right. Then let us write minus y this side. Okay, my children? Then 2y is equal to e power x into, let us write here because integral, because y dash is equal to e power x into sin x. Yes or no, my children? Right. Understood this point, my children? Right. Then 2y into e power x common sin x minus cos x plus c. Integration part is also over. We have written the common factor and we have simplified that terms. Okay, my children, this is the general solution of the given differential equation. And what is asked here? We have to find the equation of the curve which is passing through, this curve is passing through the point 0, 0. Yes or no, my children? This is passing through, given this curve is passing through passing through 0, 0. Means we have to substitute x is equal to 0 and y equal to 0 in this equation. Okay, my children? Right. This implies 2 into 0 is equal to e power 0 into sin 0 minus cos 0. Understood this point, my children? Plus c. I have substituted x is equal to 0 and y is equal to 0 in this equation. Then we get the value of c. Then we get the particular solution of the differential equation. Okay, my children? Right. So here we get 0, e power 0. Any number to the power of 0 is 1. 0, sin 0 value is 0, minus cos 0 value is 1. Okay, my children? Understood this step? Right. This implies what we'll get here? 0 is equal to minus 1 plus c. This implies c is equal to 1. We got the value of c. Now let us substitute plus c is equal to 1 in this equation of the curve. Therefore, the required equation of the curve. Therefore, the required equation of the curve is 2y is equal to e power x into sin x minus cos x minus 1 because plus 1 plus c is equal to 1. We are substituting c value. Okay, my children? This implies what 2y minus 1 is equal to e power x into sin x minus cos x. you can stop by this step also. Nothing to worry, my dear children. Or you can write some more steps. That is enough. Okay, my dear children. Understood? Right. Here I am not explaining the question number 16. Okay, my dear children. Because question number 16 is same as that of question number 15. Please try question number 16 yourself, my dear children. If you have any doubts, ask your doubts and get your doubts clarified. Okay, my dear children. Now come to the question number 17. Find the equation of a curve passing through the point 0, comma minus 2, given that at any point x, comma y on the curve, the product of the slope of its tangent and y coordinate of the point is equal to the x coordinate of the point. Understood this question, my children? Right. Here we have to write the first differential equation for the given data. What is given? The product of the slope of the its tangent. Okay, my children. So come to the solution part. Slope of the tangent. Slope of the tangent at any point at a point x, comma y. At a point x, comma y to a curve is equal to, how do you denote? Dy by dx. Okay, my children, you have to remember this point. Slope of the tangent denotes dy by dx. Yes or no, my children? Right. Now, what is given here? The product of the slope of the tangent and y coordinate of the point is equal to. Okay, my children. Here given the product of the slope of the tangent and y coordinate is equal to the x coordinate of the point. Okay, mention this is the given data in the form of a sentence. We have given this condition. So we write this condition in the form of an equation. What is the slope of a tangent at this point x, comma y? Dy by dx. So dy by dx into y coordinate. What is the y coordinate? Y only. So this implies y into dy by dx. This is the product of y coordinate of the point and slope of the tangent at that point. Understood this? Y into dy by dx, my children? Right. Is equal to, what is the x coordinate of this point? X only. So we wrote this entire statement. We wrote this entire sentence in the form of an equation like this. Understood this equation, my children? Right. Now this is a differential equation of first order, first degree. Okay, my children. Now by separating the variables, here the function in y is there, here the function in x. So we had to transpose dx to that side. Okay, my children. By separating the variables. We get y dy is equal to x dx. We transpose dx to that side. Okay, my children, understood this point? Right. Now after separating the variables, what should we do? integrating on both sides. Yes or no, my children? So integrating on both sides. This implies integral y dy is equal to integral x dx. Okay, my children, understood this step, right? What is integral y dy? Y square by 2 is equal to integral x square by 2. Okay, my children, understood this one. So integration part is over. Let us add the constant of integration. Understood this point, my children? Understood this step here, because integral x dx or x to the power of n dx is equal to x power n plus 1 by n plus 1. We used this formula for LHS and for RHS as well. Understood this step, my children? Right. I wrote the previous step again here. Okay, my children. This is the general solution of the given differential equation. But we have to find the particular solution of the differential equation with the help of the given data. What is given? This curve is passing through 0 comma minus 2. Yes or no, my children? This given that this curve is passing through the point 0 comma minus 2. This implies, since this curve is passing through this point should satisfy this equation. Okay, my children, means we have to substitute this point in this equation where x is equal to 0, y is equal to minus 2. Okay, my children. So minus 2 whole square by 2 is equal to 0 square by 2 plus c. Understood this step, my children? We are substituting x is equal to 0 and y is equal to minus 2 in this equation. Then we got this step. Okay, my children? Right. This implies what we get here? 4 by 2 is equal to 0 plus c. Understood this step, my children? Right. 2 1 times, 2 2 times. This implies 2 is equal to c. This implies c is equal to 2. This is the value of c. Therefore, we substitute x c is equal to 2 in this equation. Then we get the required equation of the curve. Okay, my children. By substituting c is equal to 2 in the above equation of the curve, we get the required equation of the curve. Therefore, required equation of the curve y square by 2 is equal to x square by 2 plus c. What is c here? 2. Okay, my children. Understood? Right. Here I am not explaining the question number 18 because question number 18 is also same as that of question number 17. Okay, my dear children. Please try question number 18 yourself. If you have any doubts, ask your doubts and get your doubts clarified. Okay, my dear children. Right. Come to the question number 19. The volume of a spherical balloon being inflated changes at a constant rate. Okay, my dear children, understood this point. If initially its radius is 3 units and after 3 seconds it is 6 units. Find the radius of the balloon after 3 seconds. Okay, my dear children, understood this point. Understood this question, my children? Right. What is given first? The volume of a spherical balloon being inflated changes at a constant. Okay, my children. So given first, let us write. Given the volume of a spherical balloon being inflated changes at a constant rate. Okay, my children. So let us write this sentence in the form of an equation. dV by the rate of change at the time of the concepts of rate of change in the n object. We have discussed that point. dV by dt is equal to A, because the rate of change in the volume is given as a constant, where A is a constant. Where A is a constant. Okay, my children, understood this step? Right. Let us consider this is equation 1. This is equation 1. And we know that volume of a spherical balloon. What is the formula? 4 by 3 pi r cube. Yes or no, my children? Right. We know that V is equal to 4 by 3 pi r cube. This is the formula. Do you remember this formula, my children? Volume of a sphere, 4 by 3 pi r cube. Let us find dV by dt, differentiating with respect to t. Okay, my children. Then d by dt of V is equal to d by dt of 4 by 3 pi r cube. Okay, my children. Here the differential operator is d by dt. So I wrote d by dt on both sides. Understood this step, my children? Right. This implies d by dt of V. How do you write? dV by dt. Yes or no, my children? Right. 4 by 3 pi is a numerical coefficient. Okay, my children. Into d by dt of r cube. What will you get? 3r square into dr by dt. Here we used the d by dx of x power n formula and also chain rule. Okay, my children, understood? Right. So here 3 gets cancelled. So dv by dt is equal to what will get to 4 pi r square into dr by dt. Okay, my children, understood this step? But actually dv by dt is equal to a. Yes or no, my children? Right. This implies 4 pi r square dr by dt is equal to a from the equation 1. Understood this step, my children? Right. So I have written that last step again. 4 pi r square dr by dt is equal to a. Okay, my children? Now this is a differential equation. Let us solve this differential equation by separating the variables. Here the function is in r, there is no function in t. So let us move this one this side. 4 pi r square by separating the variables, we get 4 pi r square into dr is equal to a into dt. Okay, my children, understood this step? We have separated the variables. Here we are using the separating the variables method. Okay, my children, to solve this differential equation. Now integrating on both sides. Do you remember this step, my children? Right. So integral 4 pi r square dr is equal to integral a dt. Understood this step, my children? Right. Here 4 pi is a numerical coefficient. We can write it outside. 4 pi into integral r square dr is equal to integral dt. Here also a is a numerical coefficient. That is why we wrote them before the integral sign. Understood this step, my children? Right. This implies 4 pi integral x power n dx formula. So r cube by 3 is equal to a into dt. Okay, my children? Let us consider this is equation 2. Because integral x power n dx is equal to x power n plus 1 by n plus 1 and integral x dx, integral dx is equal to x. For LHS we used this integral formula and for RHS we used that integral formula. Okay, my children, understood? Right. So we got this one plus c. Integration part is over plus c. Let us consider this is equation 2. Okay, my children. Now what is given? R is equal to 2, 3 units at the initial stage. Yes or no, my children? Given radius of the sphere, radius of the balloon at the initial stage. At initial stage is 3 units. That is t is equal to 0 seconds and r is equal to 3 units. Okay, my children, we can write this sentence in this form. Initial stage. Okay, my children. So t is equal to 0 and r is equal to 3. Let us substitute these two values in the equation 2. Substitute by substituting t is equal to 0 and r is equal to 3 in the equation 2. We get, what we get? 4 pi into 3 cube by 3 is equal to a into 0 plus c. Okay, my children, we are finding the value of c from this equation by substituting these values. Means we are finding the particular solution of the differential equation. Okay, my children, understood this point? Right. Here, understood this step, my children, by substituting t is equal to 0 and r is equal to 0 in this equation 2, we get this step. Okay, my children. Then what will get? 4 pi into 27 by 3 is equal to c. Okay, my children. 3 once and 3 9 times. 9 fours 36 pi. So c is equal to 36 pi. So we got the c value. Now let us substitute this c is equal to 36 pi in the equation 2. Then we get a particular solution of this differential equation by substituting c is equal to 36 pi in the equation 2. Then we get 4 by 3 pi r cube by 3 or 4 by 3 pi r cube. 4 by 3 pi r cube is equal to 80 plus 36 pi. Okay, my children, understood this point? Right. And what is given? After 3 seconds, radius of the balloon is 6 units. So now my children, let us consider this is equation 3. Given that radius of the balloon, after 3 seconds is 6 units. That is, after 3 seconds, then t is equal to 3 and r is equal to 6. Okay, my children, we can write this data in the form of these two equations. T is equal to 3 and r is equal to 6. Now let us substitute t is equal to 3 and r is equal to 6 in this equation 3. Okay, my children, understood? Right. So by substituting t is equal to 3 and r is equal to 6 in the equation 3, we get 4 pi by 3, 6 cube is equal to a into 3 plus 36 pi. Okay, my children, understood this step? Right. This implies 4 by 3 or 4 pi by 3 into 6 cube is 6 into 6 into 6 is equal to 3a plus 36 pi. Okay, my children, understood this step? Right. 3 one times, 3 two times. Okay, my children. Then what will you get here? 4 2 8. 8 6 48 into 6 308 is equal to 3a plus 36 pi. Okay, my children, 4 2s are 8, 8 6 are 48, 48 6 here. Okay, my children. 288 pi. Okay, my children, understood this step? Now let us find the value of a from this equation. So 3a is equal to 88 pi minus 36 pi. Okay, my children, understood this step? We transpose this 36 pi to LHS, then it becomes minus 36 pi. This implies that 3a is equal to 252. Okay, my children, pi 252 pi. This implies a is equal to 252 pi by 3. Okay, my children, understood this step? We transposed 3 to RHS, then it becomes by 3. 3 1 times 3, 8 times 3, 4 times. This implies a is equal to 84 pi. 84 pi. So we got a value also. Okay, my children. Now let us substitute a is equal to 84 pi in the equation 3. By substituting a is equal to 84 pi in the equation 3, we get 4 by 3 or 4 pi by 3 r cube. 4 pi by 3 r cube is equal to 84 pi t plus 36 pi. Okay, my children, understood this one? Right. So from this equation, we have to find the value of r in terms of t. Okay, my children? Right. Thirty-six pi. Okay. Now let us find the value of. So let us take the common factor pi. 4 pi by 3 r cube is equal to. Let us take pi common and we can take what is the HCF of these two numbers? 84, 72, 2, so 12 pi. Let us take 12 pi common. Okay, my children, from these two terms, let us take 70 plus 3. Okay, my children, understood this one? Right. Here 4 1 times 4 3 times pi gets cancelled. Okay, my children, understood this step. So r cube is equal to, let us transpose this 3 to that side. So 9 into 70 plus 3. Okay, my children, right. This implies r cube is equal to 63t plus 27. By distributive property we get these two terms. Understood this term, my children? Right. This implies r is equal to 63t plus 27 whole power 1 by 3. This is the value of r in terms of t. At t seconds, radius of the balloon is 63t plus 27 whole power 1 by 3. Okay, my children, understood? Right. Here I am not explaining the question number 20, 21 and 22. Please try the question numbers 20, 21 and 22 yourself, my children. If you have any doubts, ask your doubts and get your doubts clarified. Okay, my children. Right. To solve the questions 20 and 21, please refer to the example 14. The page number 395, example 14 is there. With the help of the example 14, please solve the question number 20 and 21. Okay, my children, understood? Right.